Hey guys, this is Professor Janacek. I want to talk about integration by substitution. You can think of this as the reverse of the chain rule. So if I'm integrating f of g of x, notice that is a composition, f composed with g, and then here attached to the back I have g prime of x dx. That can also be written as the integral of f of u du, where we use this substitution where u is equal to g of x. So this is often referred to as u substitution because we'll let u equal to g of x there. Now, I want to point out that we will have to make sure we have g prime of x dx there in the back, and that's the part that becomes our du. So we start by letting u equal g of x, and then we check to see that we have g of x dx there in the back. So let's try some examples. Let's take a look at example 1 here. We're going to integrate 2 times 2x plus 1 cubed dx. So what do we let u equal? Well, it's common to let u kind of be this inside function. Remember, this is a composition, and you're going to take that inside function, which is g. So in this case, let's let u equal to 2x plus 1. Then that means that du is, again, I'm thinking of the derivative of 2x plus 1, and so du ends up being simply 2 dx. So looking back at my function here, what do we have? Well, let me rearrange things just a bit. I'm going to integrate, let's take the 2x plus 1, that's my u, keep that first, and then I'm going to move this 2 to the back, and so I have 2 dx. So notice what we have here. I have, there's u, right? And then here in the back, there is du. Perfect, that's what we want. So all in all, if I look at it in terms of u, in terms of u, we have the integral of u cubed, and then du is there in the back, okay? And of course, we can integrate that. The integral of u cubed du is simply 1/4 u to the 4th plus c, don't forget that arbitrary constant there in the back. So in terms of x's now, I can write this as 1/4, notice I'm just following my little pattern here that I've developed, 1/4 times u, remember u is, where'd that go? U is, here we are, u is 2x plus 1, but now it's raised to the 4th power plus c. And there we go. All right, example number 2, I have the integral of 10e to the 10x dx. So again, I'm looking for kind of this composition, the inside of the composition. Notice I have a composition here, e to the 10x. That's a function within a function, so I'll let u be the inside piece of that. So u is 10x, and then if u is 10x, du would simply be 10 dx, okay? All right, so that means I want to go ahead and reorganize stuff over here. Let me get that stuff with the u together, so the e to the 10x I'll write first because remember that u is the exponent. And I'm going to go ahead and move this 10 to the back with the dx. So again, now you can see I've got u here, there's u, and then here in the back, that's important, I've got all of du. So if writing this in terms of u's, this is e to the u du is what we're integrating. Of course, integrating that is quite simple. The integral of e to the u du is simply e to the u. Of course, this is an indefinite integral, so it's plus c, that arbitrary constant. So now if I come back over here and rewrite this in terms of x's, again, I'm just going to follow the pattern that I've developed here. It's e to the u, but u is 10x, and then plus the constant. And there you go. All right, that wasn't so bad. Let's take a look at this big, long polynomial problem. Let's integrate x to the 4th times x to the 5th plus 6 raised to the 9th power dx. Again, thinking of this composition, u is going to be the inside of the composition, which is x to the 5th plus 6. And then if I find du based off of this, it's simply, let's see, 1/5. Do I have this? Yeah. 5x plus c. I'm sorry, I'm getting those confused. 5x dx, 5x to the 4th dx. Whew. There we go. Okay, so on this one, back to my x's. All right, if I move things around, it's all looking pretty good. There's my u, and then x to the 4th I'll put here in the back. And so I have u here, there's u, but I don't have all of du. In fact, I'm missing the 5, right? So this 5 here is what's missing. I need that in there. Let's see. Well, I know exactly where it needs to be. I know I need the 5 in here. And I know I can't just go putting 5s wherever I want, but if I multiply by 5, the way to kind of balance that is by multiplying by 1/5. And now I see I've got everything that I need, right? I have, here's u, like we'd already said, and now here in the back, here's du, all of that there in the back, exactly as I need. So what I'm really looking at in terms of all u's, I have a 1/5, and then I'm integrating u to the 9th du. So again, notice all of this, all of this is u, and then all of this in the back is du. All right, so in order to integrate this, I still have this 1/5. Integrating u to the 9th du, well, that's simply, what is that, 1/10? U to the 10th plus c. Now if we do that with our x's, we've got it with our u's there on the right hand side. With our x's, we have 1/5, and then it's going to be 1/10 u to the 10th, but u is x to the 5th plus 6, all raised to the 10th, and then plus c. And there we go. All right, now we've got one more. Let's try the integral of cosine cubed x plus sine x dx. To begin with, what should we let u equal? Well, again, think of that composition of functions. I want whatever's inside. In this case, I notice that I have I have cosine x raised to the 3rd power. Well, that is definitely a function within a function. So I'm going to let cosine be the inside function. Let u be the inside function, which is cosine. Then du is the derivative of that. Well, the derivative of cosine x is negative sine x dx. And so if I look at what we've got here in our original problem, I've got the cosine, I've got the sine x dx. What's missing is we need a -1 in here. We're supposed to have a negative there in front, right? I need this bit here, so I put it in there. Of course, I also know I can't just go multiplying by -1 to balance it out. I'll multiply by another -1 on the outside. All right, so now I think we've got everything. Notice I've got u, I've got u here, there's u, cosine. Actually, you know what, let me write this one more time just so we can see. I've got this -1 on the outside, and then this is cosine x to the 3rd power, and then here in the back I've got this negative sine x dx. I think it's a little easier to see in that form. So you'll notice I have u here, need that, and then here in the back I have all of du, so I've got to have that entire du bit there in the back. So We still have that negative 1 in the front, but what we're integrating is u to the third du. Well, to integrate u to the third du, well, that is 1/4 u to the fourth. All right, make sure that's a 1/4 in there. And of course, plus c. So now, if we are looking at this in terms of our x's, still have that negative 1 out there. And then we have the 1/4 times u to the fourth. Remember, u here is cosine. Raise that to the cosine of x, raise that to the fourth, plus c. We can clean that up just a wee bit, write it as negative 1/4 cosine to the fourth x plus c. And there you go. Enjoy!